Hi guys, it's Dr. Ford here, hoping to give you guys a little bit of help on your recent homework. Um, so I wanted to show sort of where I hope we are and um, give you a little explanation on some of the skills we're trying to get from the latest homework. So we should be familiar with how to use a balanced equation like this and how we would use the molar ratios to, for example, figure out how many moles of ammonia you'd get given a certain number of moles of nitrogen. Now, where we'd like to go is instead of working in these chemical units, we need to begin to think about working in lab units, so mass, volume, things like that. So we're going to start with mass and show how you can work with masses and say, for example, given a certain mass of nitrogen gas, how much ammonia would you make? Okay, so the concept that we need is molar mass. And that's simply the mass of the mass of 1 mole of a given substance. Okay, and I talked before in my last movie about how you could calculate this quantity. And it's pretty easy. All you really need to do is add up the masses of each individual component that makes up the compound. So for example, if we wanted to get the molar mass of nitrogen gas, for example, all we would need to do is, from the periodic table, the mass of 1 atom of nitrogen is 14 atomic mass units. All right, and then we have 2 of them because nitrogen is a diatomic gas. And then we get our 28 atomic mass units per molecule of nitrogen. All right, now what we can do is we can switch out the units and use the exact same numbers. So instead of atomic mass units, if we want to work in the real world scale, atomic mass unit is obviously very small, but what we can do is keep the numbers and switch the units. So we can take 14 grams times 2 atoms equals 28 grams of nitrogen gas per mole. Okay, so grams per mole is going to be our unit for molar mass. Right, and as we said, Ms. Lockfader draws a little heart around mole. Everything has to go through the mole. Before we can use these molar ratios, we have to convert grams or volume. We'll do that later. But for now, we have to convert grams into moles before we can play with this. All right? Okay, so for example, let's say how much ammonia can be made from 1,221 grams of hydrogen gas and excess nitrogen. Sorry, I can't make subscripts here, but so because we have an excess of nitrogen, we don't need to calculate that or worry about that. The number we're going to work with is this 1,221 grams of hydrogen gas. So we're going to gather our knowns. Okay, one of our knowns is 121 grams hydrogen. The other known is molar mass of hydrogen gas, and that is 2.02 grams per mole. If you don't know how I did that, or you can't figure it out, Basically all I did was add up the molar mass of hydrogen and then multiply by 2 for 2 atoms. Okay, the unknown would be the mass of ammonia. So we have an unknown number of grams of ammonia. But we do have one known. We know the molar mass of ammonia because we take 14 grams per mole for nitrogen plus 3 times 1 gram per mole for hydrogen equals 17 grams per mole for ammonia. All right. We also know the ratio of the molar ratio of hydrogen gas to ammonia. So we know that for every 3 moles of hydrogen, we get 2 moles of ammonia. All right, so now we can proceed. All right, so the first step would be to change the grams of hydrogen into moles using the molar mass of hydrogen. Okay, so what we want to do is we want to take and you can do this in individual steps or you can do this all in one big step. It's up to you. Grams hydrogen and then we're going to multiply this by times I. Oy. I don't like this tool here. Bear with me, please. So then we have, on the bottom, we want our units to cancel, so we'll have 2 grams per 2 grams of hydrogen gas equals 1 mole hydrogen. Okay? Alright, so that will give us the number of moles of hydrogen gas that we're working with. So we could either divide that out now or we can keep going. We can actually keep going with this. So we can then pop in the molar ratio. We can say that for every 3 moles of hydrogen, we have 2 moles of ammonia. All right, so that would, if we went ahead and divided out now and worked this out, we would get the number of moles of ammonia that we're going to get. But what we actually want to know is how many grams of ammonia we're going to get out of the 1,221 grams of hydrogen gas. All right, so our final conversion factor is the molar mass of ammonia. So if we have 1 mole ammonia and that equals 17 grams. All right, so that's the sort of thing we're going to be working on and building on. I just thought I'd take a minute, help you guys out with your homework here. I don't like this software. This is what I have on my home laptop, nearly as much as a smart board, but it is nicer than not having anything for you at all while you're doing your homework. So good luck, and I'll see you tomorrow.